Okay guys, today I want to show you the PiModem. So for that purpose, I'm going to turn on my trusty old laptop, my ThinkPad that you've already seen me working on, and while it's booting up, which will take quite a while, I'm going to show you the outside. I've built this inside an old Acer Bluetooth modem, and I basically replaced everything inside. Here in the back, here used to be the Bluetooth antenna, and this is now a Wi-Fi antenna, power jack, on-off switch, and where the phone line used to connect, I have put a standard 9-pin serial connector. And yeah, let's go to Windows first. And I'm just connecting it using a standard cable and a barreled connector for power. And it uses 5 volts, and right now I'm powering it from this standard power bank, so that lasts like forever. It doesn't use a whole lot of power. So right from the start, I'll have to be honest, there's one little downside to it. It has no real carrier detect signal on the connector. The only signals present on the connector are RxTX, the data lines of course, and RTS-CTS for flow control. So these are really important, especially if you go higher speeds. But it doesn't have the ring indicator or carrier detect lines, at least not in this version. The software by default doesn't support it, so I changed quite some things in the software already. I might try to change that in the future, but not for this one. But it still works. It works just fine with all kinds of old software. And yeah, for a first demonstration, if Windows finally boots up, I'm gonna connect to the internet using the good old dial-up software, just as a demonstration, but it works with every system that can use PPP, which are most of them. Like almost every software that is designed to connect to the internet will support PPP, like the Sting package on the Atari ST, for example. And I don't have an Amiga, but I'm pretty sure there's a PPP dial-up software for the Amiga as well. So yeah. It will still take a while, so I am gonna tell you. Inside here is an Orange Pi Zero, which is a absolutely tiny little computer. It's maybe half the size of a Raspberry Pi, and it is connected to the serial port with a custom little adapter that I've built. And I should have some more of them around here. Yeah, here they are. So these are the little boards I made especially for this, and they use a chip that's called Max 3232. And what it does is it basically takes TTL UART inputs and generates the voltage levels for the serial port. And all it needs are these few 100 nanofarad capacitors, and it has 2 receivers and 2 transmitters. So that's enough for the RX and TX and RTS CTS lines. And yeah, I've just made them on this little board and wired it up. So as you can see, it only took 2 wires, and everything else is just the leads from the capacitors themselves. So yeah, that's that. And now we've booted into Windows. I'm going to move the camera a bit closer so that you can see the screen a bit better. And I gotta turn down this, so because if I run at full brightness I can see it very well, but the camera doesn't pick it up very good. So I already configured everything. Let me just show you. In the control panel, so here is modems, and you can see maybe it's a standard 9600 bit per second modem. Oh, and of course I did not turn on the modem actually, so let me just do that and show you what that looks like. So I just pushed the button on the back, you see the power LED coming on, and now we're basically waiting for the next LED to turn on. Yeah, the camera has no focus day today. But there it is. The green light tells us that the modem, the orange Pi inside, has booted and it's now ready. So let's go back to the screen here. And I'm just going to run the standard diagnostic thingy of Windows itself, which will take a moment. And even though it doesn't have, yeah, you can see there's, it's all fine. It only shows one error. That's because of course this one does not have any fax compatibility. But yeah, aside from that, it's a standard modem. So now I'm going to move the camera away a bit so you can see the activity lights on the modem while I'm dialing. And I'll just start Firefox, and it will bring up the dialing window all by itself. Of course, it takes a while to start Firefox on this machine. Oh, come on. I've had some problems before because basically I messed up the software, so okay, we want a new session. Okay, there we go. Now it brings up the, some of you might know this from the past, the dial-in window, and I'll just click on connect. And you can already see the carrier detect. So the modem has established the connection. And Windows is now just waiting for the confirmation, which takes a few seconds. And you can see the RX and TX lights flashing. They are a little bit different from a classical modem. On a classical modem, they were basically indicating the traffic on the phone line, but since we're not having a phone line, these are now indicating traffic on the serial port. So there comes a request for my local network drive, and there we go. It's transmitting data, and it will try to open mozilla.org, but it will fail because Windows 98 doesn't support some of the modern encryption. And as you can see, we're receiving data a lot because this is running at a standard 9600 bits per second, which basically every old retro PC computer does support. But to show you that something will work, I will just open a different page. So let's say we go to www.google.com and see what it does. And you can see it's loading. Of course it takes a while, because Google is full of scripts and whatever, so that takes quite some time. But you can see the picture loading there. And yeah, that's basically the experience that a lot of us might remember from the early days of the internet, when we had like 9600 bit or 14.4 kilobit modems or stuff. And yeah, that was basically what the internet looked like back then. But we're not going to continue that because I'll just disconnect. There we go, connection dropped. And I'll restart. And this time I'm going to go into DOS mode and show you the other nice function or application, which is more interesting, I think, especially for like old machines like MS-DOS PCs, or back to the XT days, like maybe you have an Atari PC or something like that, or something like an Atari ST or Amiga or something. And you remember the days when we used terminal programs to get into BBS systems? So I'm going to start my favorite terminal program from back in the day, which is Terminate. Oh, for some reason I don't get a local echo, but we'll just ignore that and move on. I think I could maybe with ATE1 enable that. Yeah, there we go. There we have it again. So I'll just move the camera a bit closer to the screen again so you can kind of see something. There we go. So AT commands, we all remember them, maybe. I don't know about you, but for me, using a modem and dialing into bulletin boards was the first experience with anything online. So yeah, I get really nostalgic feelings about stuff like that. And yeah, let's just open the phone book, and you can see up there the Black Ice BBS, which is my favorite BBS of these days, and open dialing, and you can already see it scrolling stuff down here. And this is the effect of it doesn't have this carrier detect pin, so Terminate is still waiting for it to get carrier detect, but that will never happen. So I'm just pressing enter here and another time, and there we are on the login screen. So I'll just log into my account. And of course you will not see my password. Oh, and I see it's logging me in on node 2, which means there is someone else online. So let's just jump out of my admin menu and check who's online. Oh no, someone seems to have left, but there's someone logging in on node 3 right now. So there might be someone else connecting. The Black Ice is rather busy BBS for these days. And the SysOp has a lot of work done here. As you can see, latest news are automatically pulled from the internet and displayed inside here. And he's made a lot of great stuff. Like, let's get into the news center, which is great. It allows you to see weather data, earthquakes, space weather, everything you can imagine. I can even, let's go into Twitter, and I say custom, and I want to see if Elon Musk has tweeted something. And of course we don't see the pictures because it's a BBS, but oh, that's interesting. He said it's easy to turn a Starlink satellite into a debris collector. That's nice. Okay. But let's get out of here. No. The other guy on the other line seems he changed his mind. So let's go into the file areas and transfer something. And I'll just go into the DOS file area, and yeah, let's see in apps. Oh yeah, Dr. Hardware, that looks nice. So let's mark that for download and then get out of here and start the download. And oh, okay, yes, we want to download that, and we don't want to log out afterwards. And there we go. And I already tried like running this with the maximum speed supported, like 11 like 115.2 kilobits, but at that speed it's not stable. So yeah, but that speed never existed, and most retro systems don't support it at all. So yeah, for 9600 bits per second, which it's set at right now, this is not too bad. And as you can see, it's constantly receiving. So as opposed to before, when we were connected to the internet, where the transmit data flashed in between a lot, this protocol modem is very efficient. And yeah, I'm just going to let this download finish, which will take a few minutes, but I will speed it up later in the video. So but in the meantime, I want to tell you a bit. The first time I built something like this, not so fancy and but somehow working, was for my Atari ST, because I wanted to get this experience again, to have to connect to bulletin board systems and just relive the experience of connecting there, uploading, downloading, chatting with people, playing door games and stuff like that. I might show a door game later on. And yeah, that was something that motivated me to get this somehow going. And on Microsoft, on MS-DOS, you can get it working over a network card and basically connect with Ethernet. But even then, you have the problem that you have to run wires, network cables, and I really don't like that. A few years ago, I switched all my systems, my PC and everything, to Wi-Fi, and I really don't want to have network cables running all throughout my apartment again. So that's why I'm pretty what's the right word? I really don't want to run network cables again. So yeah, that's why I wanted it to be wireless, and you won't get any Wi-Fi card working on DOS or even Windows 98 or something. I think there's maybe 1 or 2 Wi-Fi cards out there that have support for Windows 98. Like, there's more than that, but the problem is that the most of them only support the older unsecure encryption standards, and I would not want to lower the encryption of my whole Wi-Fi network just for one machine. And the WPA2 standard I think there's really just one or two cards that support it and have drivers that are compatible with Windows 98. You might have more luck with Windows XP, but yeah, I think Windows XP is hard at the limit of being retro. But this little device, I mean, you can see it. It's just like a modem. You connect it to your PC. It's just a serial cable like you had back in the day, a power line, and it does all the work, all the translation. You don't have to worry about anything. It accepts the same standard AT commands like every modem did back in the day. And yeah, it just works. What maybe some of you might be wondering is if this will work for directly connecting to other people. And in theory it should, but I didn't have a chance yet to test this because I don't know anyone else who has the PiModem running. But as you can see right now, it's transferring binary data, so it works just like any other direct link. And the TCP-SIR, the software used, does support answering and calling in. So it should be possible to make it work so that you can connect to another person directly. And what you do is you enter the IP address as basically like a phone number, and then it connects to them. And of course they have to set up port forwarding in their local network and everything and stuff like that, but it might be a little bit complicated, but it should be possible to make it work. But it's mainly for connecting to Telnet BBS systems, or like connecting old systems to the internet. And once this download is finished, I'm also going to go into the PiModem directly, and I hope I won't mess that up again, because I want to try and change the speed so we get a little bit faster transfer rates, because it is set to 9600 bits per second, but that's just I've set it to that as a standard because basically every old system supports that. I'm not aware of any system that wouldn't support this bitrate. And if you don't have the right bitrate, then you can't access it and send stuff to it. So yeah, that's kind of a requirement. And yeah, since I will be putting up this specific modem for sale, before I sell it, I will set it back to 9600 bit per second, and so you can get into it from whatever computer you want to connect to it. Just keep in mind, once you change the connection speed, you need to connect to it to change the speed again. So if, for example, you have to be really careful, because if you set it to a wrong value at the wrong time, you're kind of screwed. If it once you've set up the Wi-Fi connection, then you can use PuTTY and on your main PC and connect over the network and change settings like that. But should you buy it and get it, the very first time you set it up, you'll have to connect to it with a serial line to enter your Wi-Fi password and connect to the network. And that is so yeah, once you've done that and you can get into yeah, once you've done that and can get into it over the network, then You can always set it back, but until that, you should be really careful. And that is one of the things I'm thinking about maybe changing in the future, that there's an easier way to change the bitrate on the fly, like with AT commands, for example. But right now the software doesn't support it. The download should basically be finished. And for some reason, there we go. It just took a while. And there we are back in the BBS. Yeah, oh. Door games are currently out of order on the BBS, so I can't show that. Okay, so let's get out of here. Oh, and there goes the fan of my laptop, which kinda sucks. But I want to show this, so we'll do ATDT 007, and that gives us the Linux login, and the user is just Pi with password orange, and it gives us this nice little login. And what we're gonna do is just sudo armbian config. It also says it right there, and it wants the password again, and that gives us this nice little menu, which has one little downside, because for some reason the arrow keys don't work. They work in the console, but they don't work as soon as you get into the program, which is kind of weird, and I don't know why that is. But we can get it working anyway. So W, and we get this and I think in here, yeah, in here you will get a list of all the Wi-Fi's that it finds. And now for some reason at least the left and right and down arrow keys work. Yeah, so here the arrow keys are working, so you would just select your particular Wi-Fi, and then it's a little bit difficult to see here because it now somehow messed up for some reason. And then where it says deactivate now, you would have the activate for your Wi-Fi, and you just go in there and type in the Wi-Fi password, and that's it. Then you're connected. I'm going to go out of here and show you another way that the same thing can be done, and that is doing sudo nano etc network, and I think it's is it inside the interfaces.d subfolder? No, it should be in the interfaces. Yeah, I don't know the right file right now. There is a file called WPA supplicant, and I can't remember right now where that file is. So it's somewhere inside etc, but I'm not really sure where it is. Oh, it has its own directory, so WPA supplicant. And it's not in there. But let's look in the script if that tells us where to find it. Yeah, I'm not very well prepared. I should have looked that up before. Okay, so no, we don't want to save anything. But you get the idea. It's just a matter of entering the right values into the right file, and that's basically it. I think it can be entered in the network.interfaces file, but I'm not 100% sure. Yeah, but you get the idea. I will provide more detailed explanation once I actually get it ready for shipping. There's one more thing. Let's just get back in there. Pi orange and open ALSA mixer. And that doesn't like the arrow keys again for some reason. I don't know why, but somehow arrow keys are a bit quirky. Yeah, basically, maybe you can hear it, but the modem should also make the classic modem noise whenever you connect to something, and it seems I forgot to install that again. Let's just check it. But you can see it's just like any serial connection. Oh yeah, there we are. So here's all the files that are important for it, and I just forgot to copy the playsound.sh to user local bin, and that's one of the things that I added that the software originally didn't support. So now there it is. If we now exit and let me just put my microphone a bit closer to the modem and show you the modem itself. And I'll connect again. So yeah, it makes this noise as soon as it's connected when the LED turns on, which is not quite how it worked back then, but yeah, it's the closest I could get to the original experience. So yeah, that's the PiModem. Oh, wait a minute. I almost forgot that. But I promised you that I want to try and change the speed. And of course, I am going to do that. So, connecting again, ATDT 007. And login, Pi, orange. And I do know the file for that one, so that's sudo nano user local bin start tcp cert.sh. Enter the password again, and there we are. And now I hope the arrow keys work. They're a bit flaky because we need to get to here. And it seems to help if you push them slowly. And let's change it to 19200, which is kind of a common speed of the time. It messed up on the screen right now, but I think that should be just on the screen and not in the actual file. So I'm going to press Ctrl X and say yes, write the changes. And now open it again to see if it worked. Okay. It needs to be 19.2. So this should be right. Control X, save the buffer. look again. That's right. So you always want to double check that it's absolutely the right value, because once you do what I'm going to do now, so you can, to activate the changes, you could basically just turn the modem off and back on again, but you don't have to. You could also tell it to reboot via command, but you don't have to do that either. You can just do sudo service tcp ser restart, and we're not going to get an answer now, because now it is set to a different baud rate. So I'm going to enter the setup, the port setup here, and select 19200 baud and save that. And now modem init, and it works. So let's dial into the BBS again with double the speed. And I'm going to log in and, just for fun, download another small file and see if it's stable. I mean, that would be the process you go through when you want to actually, let's say, tune it for the best performance. Yeah, now it really doesn't like the arrow keys. I don't know what's up with these. Maybe someone can find out why it is that the arrow keys are especially refusing to work a lot of the time. I really don't know why that is, but I'll just pick the first file for now. And say download. Yes. And there we go, it's transferring the file. And as you can see, it's roughly twice as fast as before. And I think it's dependent on the terminal program that you're using. For example, the terminal program I was using on my Atari ST, it doesn't have problems like that at all. Like there, the arrow keys worked just like normal. So I think this is a problem with Terminate that I just haven't figured out yet. And you can see this time, okay, it's a smaller file, but it goes much faster than before. There we go, almost done. And that's it. So I think that concludes the demonstration. And yeah, if one of you wants to have this nice little device, it'll be up for sale on Facebook really soon. And goodbye.